All right, we're going to be dealing with the slope of a line today. So, slope in words, the slope m, so we use the variable m to represent slope, of a non-vertical line is the ratio of vertical change, aka the rise, to horizontal change, aka the run. So the algebraic way of representing that is we're going to use m as our variable we typically use for slope, but we also have a tendency to use the variable a. So I want you to kind of get used to seeing a, lowercase a, in place of that. And usually the rest of the world uses a and not m, but in the States here we like to use m for some reason. Anyway, so we represent that as delta y over delta x, where delta, maybe you can recall this from a science course, means change, how something changes. So it's the change of y over change of x. And change is represented by subtraction in mathematics. So when we subtract things, we find how much they change by. So in our formula here for finding slope, it's y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And the difference of the rise, your y, which runs up and down, versus the difference in your run, your x's. So hence you get your rise over your run. So graphically, the slope tells us how steep that line's going to be based off that ratio of rise to run, how much the rise is changing or the y is changing versus how much it's changing on the horizontal. And so in our little graphical representation here, you can see the rise is going up so many units and the run is going over so many units. In other words, how far are you changing upwards to go from this first point to that second point? How far up do you have to go? And then how far to the right do you have to go? And that's going to be your slope. So, know those three representations of slope. Now, let's look at an example of where you might see slope. So here's a skateboarding example for all you skaters who like to skate on ramps and stuff. A skateboard ramp has a rise of 15 inches and a run of 54 inches. What is its slope? Well, we have a nice little handy-dandy illustration here. We can see that our ramp here, which looks remarkably like a right triangle, has a rise of 15 inches. It goes up 15 inches in the air and it runs along the ground 54 inches. So if I want to find the slope, a or m, I like to use a. But you can use m, but a is probably going to be the preferable variable of using for slope. And so again, it's our change from a rise 15 inches in the air, so from ground 0, the ground 0 inches to 15 inches. We're going to go, that's a difference of 15, so we're rising 15, and then we're going to run 54. Okay, so if we call from here, we're 0 inches along, we're moving to the right 54 inches. So 15 over 54. So in other words, I'm going to stick with a here, I can reduce that to 5/18. So my slope in simplified form is 5 over 18. That is an ugly 18. But there it is. Okay, cool. Now, moving on. In our next example, we want to find what is the slope of a line that passes through -4, -5, and 6, -2. Well, for something like this, we want to do the algebraic process of finding a slope. So, remember, again, I'm going to stick with using a. We have y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And I like to label my points. That's a good idea because the number one mistake that people make when they're trying to find something like slope is they get their numbers switched around. So I'm going to call this my first point. So I'll call this x1, y1, and I'm going to call this other one my second point. So I'll call this x2, y2. So x sub 2, y sub 2. It doesn't matter which one you call the first or second point, as long as you're consistent about, you know, your x's and your y's, you're good. So I'm just going to simply substitute that into my equation. So that's going to look like y sub 2, which is negative 2, minus negative 5, my y1, which is like saying plus positive 5. Then I'm going to go x sub 2, which is 6, minus x sub 1. So minus negative 4. Again, because the minus negative makes it positive. Thus, I'll have a slope of 3/10. So A, my slope, is 3/10. So we just found it algebraically. So not too bad. Moving on. Okay, we can classify our slopes. There are 4 different classifications of slopes we can use. The slope of a line indicates whether the line rises from left to right, falls from left to right, is horizontal or vertical. Okay, so if you look at a graph of a line, like you read a book from left to right, you'll see that if it goes up, that is a positive line. It goes up. It's all positive. And then if it goes down, we call that a negative sloped line. Okay, so it descends. And if a line is completely horizontal, we call that one a zero slope. It's all run, but no rise. And the flip side of that, if you have all rise and no run, that is going to be an undefined slope. It's completely vertical. Okay, so it's important that you keep straight what a zero slope looks like versus an undefined. Those are two that can be easily, you know, mistaken one for the other. So remember which one's zero, which one's undefined. Okay, think about walking. You can walk along the ground, but you can't walk up a wall, because that would just be silly. Okay, let's go ahead and classify the type of slope from given points. We'll start off with this point of 1, 6 and 8, negative 1. So we'll be using that formula to find slope. We'll be using x1, y1, x2, y2. So I'll set it up as a equals y2, so that's negative 1, minus y1, minus 6 over x2, 8 in this case, minus 1. And we'll find out we'll have negative 7 over 7, which simplifies to negative 1. So therefore, a is negative 1, and because a is a negative number, that means it's going to slope downward. It's going to descend as you go left to right. So therefore, this is going to be a negative slope. And I'm going to box that in. Okay? Now, I want you to try the next one, see if you can do that one on your own and see what you get. So go ahead and pause it in 3, 2, 1. Bam! There it is. So we end up with a equals 4 over 11, which is a positive number, so therefore this one is a positive slope. It's going to have, it's going to rise from left to right. So look at your positive slope graph, and it should look something like that. All right, let's try the next one. See if you can do that one on your own. See what you get. In 3, 2, 1. And just like magic, there it is. So we have a is equal to negative 2 over 0. But perhaps you can recall you can't divide by 0. Do you know why that is? You need to ask me that in class if you don't. So what we'll say is a is undefined. So a is undefined, or it has an undefined slope. It's not really equal to anything that is a number per se. And what that's going to look like, because it's undefined, is it's going to be that vertical line, and it's going to be at negative 5. See how those negative 5s repeat there? So it's going to look something like this on the left side of the graph at negative 5, going vertically. All right, try this last one on your own. See how you do. In 3, 2, 1. And there it is. So a is equal to 0 over negative 17, which reduces to a equals 0. So that's going to be our 0 slope. And that's going to look like a horizontal line. So there's your y-axis, and there's your x-axis. And so it's going to look like we'll probably be at 2. It will be at 2 because if you look, both of our y values are 2. So 2 is going to be repeated all along that horizontal line. Okay, so that's going to be our 0 slope or horizontal line. Okay, now let's look at example 4 where we're going to have to identify if lines are parallel, perpendicular, or neither. So line 1 goes through -2, +2, and 0, -1. Line 2 goes through -4, -1, and 2, 3. So we would use that slope formula, find the slope of both of those, slope of the line that goes through both those points rather, and compare them. What we'll notice is with the first one, in this case now we're using m again for slope, you'll have -3 over 2 for the slope of the first one, and then for the second one we're going to have 2/3. So what does that mean? Well, what do you notice about these two slopes? Any similarities or differences? What I notice is that here we have a 3 on top and a 2 at the bottom. And this one is the reciprocal. It's switched. 2 on top, 3 on the bottom. I don't notice that one is negative and one is positive. In fact, these are negative reciprocals. If they're negative reciprocals of the slopes are, then that means they're going to be perpendicular to each other. So negative reciprocals means we're going to have perpendicular lines. Like so. Alright, and so you can see that they'll be crossing, but don't trust the graph alone. You can't just look at it and say, hey, it's perpendicular, because you know it might be 80, instead of crossing at 90-degree angles, it might be 89.999 and not technically 90 degrees, and therefore technically not perpendicular. Okay, let's look at the next one. Are these lines parallel, perpendicular, or neither? Or neither? I don't know. I have to settle on one of those pronunciations. So line 1, we have point through 1, 2, and 4, -3, and line 2 goes through -4, 3, and -1, -2. So again, we would use that formula, y2 over y2 minus y1 over x2 minus x1, and we would find the slopes for both of these to be exactly the same. Now, because they're the same, may mean that they're perpendicular, and I'm saying may mean is because we have to know that in fact they have different y-intercepts, because you could have 2 points or 2 sets of points that have the same slope but the same y-intercept, in which case it would be the same line. In this case though, if we were to graph it out, we would see that they have different y-intercepts. So in this case it's safe to say that these are parallel lines. So I'm just going to call this one parallel. Of course, you would write that out. Anyway, there you have it. That is everything we need to know for now about slope.